All right, on page 715 today, we're going to be working with arcs. And chords. And theorem 10.2 states, in the same circle, or congruent circles, two minor arcs are congruent if their corresponding chords are congruent. In the same circle or congruent circles, two minor arcs are congruent if their corresponding chords are congruent. What that looks like is if we've got a circle, and in this circle, in the same circle or congruent circles, two minor arcs are congruent. So if we put a chord in this circle, chord AB, and in the same circle we put another chord, chord CD. What the theorem says is that if chord AB is the same length or congruent to chord CD, if those chords are the same length, then their arcs are also the same measure. Okay? If AB is congruent to CD, then arc AB is congruent to arc CD. Everybody see that? It makes sense, doesn't it? If the shape is a circle and both of the chords are the same length, well, they're going to take up the same amount of space along the arc of the circle. And you can put a little note right here. The converse is also true. Meaning if two arcs in one circle are congruent to each other, okay? You could say if arc AB is congruent to arc CD, then segment AB is congruent to segment CD. So if you look at real world example number 1, you're given a circle down there. They call it embroidery hoop. In this embroidery hoop, we got AB right here. We've got CD down here. You're told that AB is congruent to CD. You're told that arc AB is 60 degrees. You're asked to find the measure of arc CD. So the measure of arc CD is equal to 60 degrees. And then if arc AB is equal to 78 degrees, then arc CD is equal to 78 degrees. All right, turn the page. Now we're going to use this same rule and just incorporate a little bit of algebra. So we've got two circles now. And in the first circle, we've got chord NM. And chord NM is 2x plus 1. And we've got a tick mark here. In this second shape, we've got another chord, PQ. You're told that arc PQ, and you're told it by tick marks, that arc PQ is congruent to arc MN. And chord PQ is 3x minus 7. And you need to find PQ. So, since the two arcs are congruent, then their corresponding chords are congruent. So if that's the case, 2x plus 1 is equal to 3x minus 7. We're going to solve for x, and then we're going to substitute. So if we subtract 2x from each side, then 1 is equal to x minus 7. Can add 7 to each side. So 8 is equal to x. If 8 is equal to x, then PQ is equal to 3 times 8 minus 7. 3 times 8 is 24 minus 7. That's 17. So PQ equals 17. Any questions there? If two circles are congruent and two arcs are the same length, then their corresponding chords are the same length. All right, so let's do that second example there, example 2, on the top of page 716, and then I'm going to give you some practice. We're going to go one circle this time. Chord RS. And then we've got chord TV. You're told that RS is 5x minus 9. T to V is 2x plus 3. All right, so again, if these two arcs are congruent to each other, then their corresponding chords are congruent. So if you're asked here to find RS, well, if the chords are congruent, then 5x minus 9 is equal to 2x plus 3. Can subtract 2x from each side. And 3x minus 9 is equal to 3. Add 9 to each side. 3x is equal to 12. And then divide both sides by 3. Our x is equal to 4. But if we need to find RS, then our RS is equal to 5 times 4 minus 9. So RS is equal to 20 minus 9, which is 11. RS is equal to 11. Any questions? Pretty straightforward, huh? Okay, so your practice for today. Let's go with, we're going to start on page 718. One through 3. Then over on the next page, problems 7 through 15. All right, again, make sure you're checking your odd answers in the back of the book. You're completing your practice problems today and your electronic assignment tonight. Completing the practice problems today and the electronic assignment tonight.